Um, this is not an exhaustive list. There's more, but I will try my best because I like to talk and time doesn't like talkatives. I will try my best. We will just look at a brief overview on security on AWS. So when you create an AWS account or you've been employed as a solutions architect in an organization, and then the company comes to you, okay, we have these users. Can you put them can you create an account for them? It creates a problem for you now. You have to find a solution. So what are the means of which you can do that? We focus on identity and access management, that is IAM, and some few things. We also look at compliance, and then how then do you secure applications? If you can secure users, that is only one end of the thread. How then do you secure application? And then hopefully we continue from there. Okay, so let's look at the AWS shared responsibility model. I know most of you have experience with that. So what is it and what does it mean? Any idea? When you see that, what comes into your mind? Anybody can just put an answer in the chat. And remember, don't try to be right. Just share your thoughts. What do you think this service or this term means in AWS? Anyone? Okay. Yes, thank you, Femi. What AWS and go on. I think you are mute. Okay. So Femi put an answer and he says what AWS and the customers are responsible. Okay, Sam, go on.
Yeah, share responsibility, to my own understanding, is that is the in the place of security. So AWS have its own part to play, whereby you also have your own part to play in that responsibility, to share that responsibility. So you decide how you want to set your own security, while AWS take care of the manage security side of it.
Okay.
That is my own understanding.
All right. Okay. Thank you. That's very good. I think Darius also says AWS handles part of the security and the user handles the other bits. All right, Jacob, go on. I see Isaac also say framework that outlines the division of security responsibilities between AWS and users. Go on, Darius.
So yeah, so on my side, I feel depending on the deployment mode, whether it's infrastructure as a service, platform as a service, that will define what is the responsibility of the customer and what's the responsibility of AWS in terms of securing the systems.
Okay. All right. Thank you. That's very good. So this is a mindset, actually. When you look at the shared responsibility model, most people want to shift blames, right? Okay, people, when something happens, they want to, even if you go to AWS and you incur a cost, let's say you go to AWS and you see $100. Okay, what happened? You begin to look for a blame. So this model is there to actually let you understand your responsibilities in AWS and then AWS also responsibilities. This depends on different services. For instance, if you are using the serverless services, the responsibility shifts. But there is one thing, AWS is responsible for the security of the cloud. And then you, the customer, you are responsible for the security or for your security in the cloud. So if you want secured services to use, AWS will provide you that with options to secure the accounts even further. You are responsible for turning on or making use of that options. So for instance, imagine if you have been given a shoe to wear. The shoe is responsible for the security of your foot. But you are responsible for the security of your foot inside the shoe. So you can decide to wear it without the socks. You can decide to even cut part of it and make it more open. You can decide to go and walk with it in the mud or wherever you want. That is your responsibility, and you bear the consequences. So when we talk about the shared responsibility model, we are saying that customers are responsible for their customer data, the applications and the platforms that they use, and importantly, the access management to their account. And when we want to talk about access management, we will look at authentication and authorization. What is AWS responsible for? Setting up the AWS cloud infrastructure, which includes networking services, database services, storage, regions, availability zones, and edge locations. So they are responsible for the setup of the infrastructure for users to use. Like car manufacturers are responsible for the setup and the design of the car. They put seatbelt in it, they put everything that you need to make the car secure, like airbags. Now, you, the customer, you are responsible for driving the car, how you protect yourself. Okay, do you leave your key in the car? Do you open the doors whilst you're driving? Do you use the seat belts? That is the shared responsibility model in terms of cloud computing in AWS. So for the user, your operating system, and in this case, if you are using services like Amazon EC2, then you are responsible for selecting the operating system, making sure you maintain it, you upgrade it, okay, you patch it. That is your responsibility. But if you are using something like Lambda, which is an AWS serverless service, then AWS takes charge of everything. You only use the runtime. So in this case, the shift goes into the security of your application code. You get it? So your instance, the operating systems, the application that you design, don't wait. Am I audible?
We lost you a bit. I thought it was only me.
Okay, no, so it was me. I'm actually on two networks right now. Felix, you can test that. MTN decided to go off, so I'm back to another backup network. All right, thank you. So security group securing access to your servers, it's your responsibility. Is my screen visible in a way?
Yes, it is visible.
All right, thank you, Darius. So when it comes to your application data, your own account, you are responsible for managing the security of it. So encryption, it's your responsibility, and we'll look at how we can perform that in there. AWS puts the options for them, a lot of options. You have to decide which one to use and which one not to use. Then you have to protect your network traffic. So if you decide to open your service to the internet and a bad actor get access to it, that is your responsibility. It is not AWS that causes it. So these are some of the security features you have to think about in the cloud. And today's lesson is going to rely heavily on that. Then what is AWS end of the bargain? AWS makes sure that the data centers are secured, physical access to data centers, even employees as authentication and authorization is done by AWS. Make sure they give you high performing hardware, like network infrastructure, make sure it is secure, performing up to the SLA signed with between you and AWS. They also are responsible for the virtualization frameworks that they use. And that is your responsibility. So let's look at this chart. Security group, whose responsibility is it? Is it AWS or the customer?
Customer.
Customer, thank you. So the customer is responsible for configuring security groups. AWS is responsible for managing the infrastructure network, that is the data center network. AWS is responsible for implementing physical security controls like access to data centers, making sure the right users have the right employees have the right access to the services. Nobody have an unauthorized access to your data. So that is it. But you are responsible for patching your own EC2 instances. Unless you use a managed service, then you shift that responsibility to AWS. And then setting permissions for your applications or your services like Amazon S3 is your responsibility. Meanwhile, AWS maintains the server that runs. So make sure that that virtualization technology is running for you. All right, so let's look at identity and then access management. When we talk about identity and access management, this is what you need to look at. To use AWS, you need to create an account, right? Hello, Darius, go on, your hand is up.
Yeah. Before we move on from shared responsibility.
Yeah, your voice is far away.
Hello? Can you hear me?
Yes, loud and clear.
Yeah, before we move on from the shared responsibility concept, does it only refer to security, or it is wider than just security in terms of responsibility?
Okay, so it is a security concept. So it is about how, what are your responsibilities and what is AWS responsibility when it comes to security? Okay, so it is mainly focused on the security of the cloud.
Okay, thank you.
Good. So when we come to identity and access management, this help us ask questions like authentication and then authorization. So when we say authentication, what comes into your mind? What do you think this word means, authentication? Go on. Darius, is your hand up or it was from earlier?
Sorry, it was from earlier, but
Okay, Jacob. All right, you can go on. Then
So
Jacob
authentication. Yeah, so authentication to me is like proving that you are the one who you are by providing your identity, probably like username, password. Yeah.
Okay, so who are you? What about authorization?
Authorization is to after you've confirmed that who you are, then it is now providing resources to the user.
Okay, all right. Okay, so imagine you are in your house, okay, and then a total stranger came and knocked on your door. What are some of the questions you ask?
who are you?
Who are you? So first question is, I know some people ask who are you in a different language. Yeah, what do you want? Get it? So when the person opens the door, who are you? And then you say, okay, I am this and this. So first of all, you have to align yourself with the person if they know you, if they can identify you. That is authentication. So it could be your username, it could be your password, it could be something that you are holding. So for instance, if you order pizza and then there is a knock on your door, that is a stranger, but the stranger is holding something, right? That is the pizza in the box. So oh yeah, I order pizza, you cannot automatically align with that person. Even though you don't know the physical person, but what they are holding makes you to identify them. Then the question is, okay, if I say, okay, my name is Joseph Tedes, what do you want? So this is, what do you want? Okay, or what is your quest? And this is what we want to talk about. So in AWS, or when you create your AWS account, you come into this screen here. And the first question is that this is you knocking. You want to get into AWS. You have to provide some few things about you, like your account ID. Who are you, of course? What is your account ID? What is your username? Okay, and what is your password? These are credentials that you need to provide to show that this is you, to prove your identity. But then there is something. If you are the one that creates the AWS account, you use what we call the root account. So you see that the questions change. With the root account, can you see my browser?
Yes, we can.
Yes, we can.
Yes. So the email address that you use in creating the account, we call it the root user's email address. So if you want to use that account to log into AWS, you need to provide that account and then the password. So note the difference here. There is an IAM user and then there is the root user. The root user is the one that created the account. The IAM user is a third-party users, okay, that you've created for your account. So the root account is used in only certain use cases. You don't use the root account for your day-to-day management of your AWS account. You create what? IAM users. And with the IAM users, you can control the authorization, which means you can give them permissions, you can deny them permissions, you can control what they can do, you can control what they cannot do. Now the question is, can you do the same for the root account? Can you control the authorization, the accessibility or resources that your root account can access? Can you control that? What do you think?
Come again? I didn't hear that.
Can you control the permissions of the root account?
No.
Okay. Who else think they can? Okay, Dairo say, I think you can. Okay, go ahead. Let's hear you.
Yeah, I think you can.
I think you can.
It's a super account, so
Okay.
it should be able to do everything.
Okay.
Yeah.
So, for instance, let's think about this analogy. If you buy a car and you are the owner of the car, can someone control what you do with your car?
No, you own the car. You
own the
control
car.
what you do with the car.
Okay. But for instance, imagine you go to a restaurant, right? With your car. Can the restaurant decide where you park your car or not?
Of course they can, because they
Okay.
own the restaurants.
Okay. So for instance, if you decide to use your car for Uber or Lyft, can Uber control some aspect of how you use your car?
They can, in some way, they can, because they own the access to the service you are using.
Okay. So a root account in their house, like you and your car in your own house, you have absolute permissions, you have absolute power over your car. And in AWS, when you create your account, you have absolute power over the account until you join what we call AWS organizations. Okay, so we will look at that. So when you join an organization, your account can be controlled. Even the root account can be controlled. So we'll look at that. But for now, in your AWS account, the root account has the full power over the account. And because of that, we don't use it for the day-to-day management of the account. Because one, if you mess up the account, there's no way you can revert the damage caused. But then you can create an IAM user, which is just a normal user, and then assign permissions. And if there is challenge, you can even delete the user and recreate a new one. So to access your account, look at this analogy. You have a cashier, okay? And you have, let's say, a coffee shop. So there will be a cashier, and then there will be a barista in the account. So what do? Do you create a root account, a root user account for the cashier, or you create an IAM user for the cashier? I'm sure, yes. Because of course, so the cashier can have the account, and then you can create the IAM user, this identity in your account. Now you can use what we call policy to control the permissions of the cashier in your account. So in here, the cashier can access certain services. You can deny them access to certain services. So now you have a higher way of controlling everything that happens in your account. There is one thing. When you create an IAM user, like this cashier, they have no permissions. So you have to now reassign permissions. And we use what we call the principle of least privilege. This is something that you are going to meet mostly, privilege. My pen is, I don't know how to spell this. Anyway, this morning I have not eaten yet. It's very early in Ghana, so that is my excuse for not able to spell privilege this morning. So forgive. All right. So you can now use the identity and access management service, which is an AWS service that is dedicated for creating users, okay, controlling the authorization of these users using what? Policy. Then you can put these users together in a group, okay, so that you can easily manage multiple group of users that perform the same tasks. And then you can also give temporal credentials, which we call IAM role. We'll look at that. And then you can also control if they have to enable multi-factor authentication in their account. So this is the root user account. And with the root user account, we said what? This is the person who creates the account. So this is the owner of the account. And they log in using what? The email and then the password that they use in the creation of the account. But the IAM user log in using the account name, the account ID. Okay, so as you can see here, the IAM user logs in with the account ID. So if I click on IAM user, you need to provide the account ID, which I don't know. I don't know my own account ID. So I'm just going to pretend I know the IAM staff. Click on that. And it will tell me, yeah, you don't know your own account ID. So now I can provide an alias to the account. Okay, so I have an alias, which is just like a speech dial to the account. And then the username, in this case, I have an admin user, but a lot of users. So this user, when this user log into this account, they are limited. How is this limitations done? Let's look at a sample. So I'm going to create a simple user, in this case, who wants to be a user in my account. Let me see. Jacob and Darius. Let me see. So to use IAM, I'm going to look for the service called Identity and Access Management in my AWS account. Open that. So imagine I've created my root account. For me not to use the root account for the day-to-day management of my AWS account, I can create an administrative user and use that credential. So I come here, see this things here. I come here, I create a user. So to create a user, I click on users and then create a user. In here, I have a couple of users already. I have an admin user. That is a user that I created, give them administrative permissions to control, to be able to use it to manage other users in my account. So if I click on this user, you will see I have permissions here. So these are the permissions. I gave the user the administrator's access. What is inside of this permission? So the permission is a JSON document, actually. And as you can see, it's written in a simple way. So we have the actions the user can perform, and then the effect. Do you allow or deny? And then the resource. So I've allowed access to all resources. That is what this asterisk is saying. This is a wildcard for everything, all. So that is it. I can create another user. So let's create a deputy user. In case I'm not there, I want to create someone who can do the management of the account in my name. So let's call this user deputy. Okay. It's just a deputy, and you have multiple users in this account. You can provide access to this account. So remember, when we are accessing our AWS account, there are several means we can access the account. We can access the account using the graphical user interface, which is what we call the console. And that's what I'm doing. I can also access the account using my IDs. So in this way, we call it programmatic access. In this way, if I have VS Code, I have an application, or I'm going to use the SDK to access AWS, I can do the same thing. So look at this in action. So I have VS Code, and this VS Code, I've given it access using the same credentials to my AWS account. So let me just go to my terminal in there, the CLI, and what do I do? Give it a second, give it a second. My CLI is a bit slow. So let's say you are a developer and you are developing in the AWS account. You have your IDE and you want to access AWS without going through the console. you can do the same thing in here. So in my terminal, whether you are using Linux, Macs, or Windows, you can do the same thing. So give it a second. I can say AWS, okay, and do STS. So I'm calling a service in AWS. So let me call this a service, and then say, okay, what authentication method am I using, or what credentials am I using to access AWS? So I will say get caller identity to see, okay, which users credentials am I using? So let me do the same thing here. Identity. Now, when I do that and press enter, my IDE is talking to AWS, but it's talking to AWS programmatically through code. So here it is just talking to the API to AWS. So you can see I have this. It says what I'm using, which user? The administrative user. This is the user ID, and this is my account ID. You get it? So I can access AWS both programmatically and then through the console. So what you see here is, it says what, provide user access to the console. It means you want your user to be able to access the console through a browser or through code. So yes, I want my deputy to do the same, and I want to just create a user. Of course, we can do multiple things. This is where you create a password for the user. So I'm going to use sample password. Let me use just something cheap so that I can remember. And then I can say, okay, the user must change the password after they log in with the password that I'm giving them, or I can say they shouldn't create a new password. So I can check this box. Let's click next, and it says my password is not very good. So let me give it a very big password. Okay. I think I have a very big password somewhere. So I'm going to use that one. Hopefully that changes. So here we can put users in a group. So if you have users, let's say we have multiple cashiers, we can put multiple cashiers in a group. Okay, so this is where we can add the users to the group. Then we can add permissions. We can copy from existing permission, or we can attach permissions. Let's not do any of them. Let's just create a skeletal user, and let's look at this. So I'm done, and I've created a user. It will just be easy. Now, if I give this credential to all of you here, you can access my AWS account using this identity as a user. So I'm going to download the credentials, and I can share it via email or either way to my users. Let's return to the user list and let's see what our deputy user can do now. So I have my deputy in here. The deputy, as you can see, contains no permissions, and this is what I mean, no permissions. So what can we do? We can attach permission policies, which is the rule book, the permission book, and give it to the users, and then attach it to the users, and then they can access our account. So how do we do that? We can click on add permissions. So click on add permissions, and then I can attach the permissions to the user that I want. Of course, if you put the users in the group, what happens is that the permissions of the group is inherited by the users. So in this case, if I have the cashier group, so this is a group of cashiers. So cashier, whatever policies, permissions, if I said full access, every member, maybe deputy is a member of this group, Jacob is a member of this group, Darius is a member of this group. All of you have the permissions, you inherit the permissions of the group. And that is an efficient way of managing large users. So usually, to ease the burden on always attaching different permissions to different users, you can use groups. But I'm not using group, I'm attaching the permissions directly, the policies directly to a user. So here are the policies. Now AWS we have AWS managed policies, and then you can create your own. So you can create your own policy. When I expand this here, you will see policies. So we can actually create our own permission policy. Remember, it's just JSON, or we can use AWS created and managed policy. Okay, I see a question. If a set policy, if I set a policy to expire passwords, would the expiration of a user password affect the functionality of their access key and the secret access key? That's a good question. So let's, I think let's continue and see what happens. Okay, so here I can, let's say I want my user to have full access to the account, but I don't want them to have access to this service, identity and access management. So they cannot change their own permissions, but they can perform almost every task in there. I can give them a policy by a job function. In this case, you can say these are AWS managed policies. It means AWS created them and then manage them, which the management includes updating them or changing them based on the new developments on AWS. You can create your own, and that is your responsibility. So this, in the shared responsibility, this is your responsibility. You have to update it. If you don't, and maybe AWS upgraded their services, then your policy is not good. Then that is your case. So I want to just use AWS manage policy by a job function. In this case, let me search for developer role. So I'm just going to say, let's say I want to give my user access, complete access, but not complete access. If you want them to have full access, then you can give them the administrative access, but I want to give them power user access. With this, what it means is that this, they can do a lot, but they cannot change their own permissions. This is a bad way of doing it. You can do it, maybe you want them to only access an S3 bucket. You can only give them access to the S3 bucket, and we call it the principle of least privilege. Now I've added that policy. Let's look at it. In the policy, we see they have access to the effects. They have access to this, it says allowed, but you see this action here, not allowed or not actions. They cannot perform an action on AWS organization. They cannot access the general accounts, but they can perform the allowed actions. So now let's look at that user. I can now sign out of my account and sign in with the credentials as the user. Let me continue to the slide. All right. So by best practices, we said what? Grant only what? Create individual users for each person who needs permanent access to the AWS account. We will see, okay, what if the person needs a temporary access? And then we control the permissions of the users using what? The policy documents. Okay, so the policy either denies or grants access. Okay, and by principle, always give only the needed policy to your access to your users. Now, how do you learn? Okay, how do you understand the AWS policies? How do you understand it? How do you use them? An AWS policy has some few things that it needs to contain. So it needs to contain a version. These are just metadata, okay? But the focus is on the policy statement. And we have two types of policies. We have what we call the identity-based policy. So identity-based policy. Now, when we say identity-based policy, this is a policy that is assigned to users, groups, roles. We call these people principals. Okay, so we can attach this policy to them. So the policy we have just attached to our user is an identity-based policy. But we can also attach policies to resources like Amazon S3 buckets or DynamoDB to kind of determine who can access those services. And we call that policy resource-based policy. So we have the resource-based policies. So these policies are attached to AWS services. All right. So how then do you know which service policy to use, or how do you understand policies? There are simple tips here. I will give you a tips on how to actually create a policy. If it is an identity-based policy, there are a few things that you need to know about it. One, I use the acronym EAR. I use the EAR acronym to understand what type of policy I'm dealing with. So the E stands for effects, the A stands for the actions, and then the R stands for the resource. Identity-based policies you can just think of this. So the effect is, are you allowing or denying access to the resource to the user, for that user? And in this case, what actions? So you see, these actions are the actual tasks that the user can perform in the account. For instance, they can list an S3 bucket and they can get objects, or they can retrieve objects in the S3 bucket. That's all we are giving them. Then the resource, what bucket are we talking about? It could be multiple S3 buckets, or it could be a particular S3 bucket in our account. So in this case, we state that. So in this case, you can see we have multiple buckets. This an example bucket, and then this another bucket. So we can write all of them here. This is an identity-based policy. And we'll look at example of a resource-based policies. Okay. Any question? Now let me address your question, Jacob. So if you set a policy on the password, it will not affect the credentials of the user. What happens is that let me go back to the account so that I show you this in demonstration. So when I come here and I click on my users, we can see information about the users. Okay, here you see the last activity. Okay, can you customize actions, or they are already pre-configured by AWS? So we have list of actions and you can select from them. Every API call, okay, that you can make on AWS, there is an action for it. So you can just select from them. So you can see the password each. I have password that has as old as 233 days. And then IAM can just tell you that you need to change the password, but it will not affect the credentials of the user, okay? Unless you specifically say that, okay, these users shouldn't be given access. When we say access keys, these are the programmatic credentials that we use in accessing AWS programmatically. So you can say, okay, change your password every 90 days. You can accept, you can create a password policy. In this case, what happens is if the users access the account and the password has expired, they'll be prompted to create new password. You get it? So you can accept that, but then it doesn't say it doesn't affect what they can do or what they cannot do. Now, for Darius' question, yes. For instance, if I want a user, let's pretend I want to attach another policy to this user, our deputy user. So I go in and click on attach policy. So I'm going to attach policy directly. Now here I want my own policy. Okay. Here you see these are customer managed policies. These policies are also pre-created, but I can create my own policy here. So policies, and I come here and create policy. So this is where I specify. Let's look at it. We have AWS policy generator that you can use, but for instance, I want them access to, let's say, S3. So I select the service that I want to control access to. You see the actions. Then these actions are API calls. Okay, because in AWS, what happens is that AWS has an API that everything talks to before they make the calls to AWS service. So I can give them all, and that is where we use the asterisk. Okay, so you see the all here, all permissions. We use the asterisk, but I don't want to do that. As a cloud practitioner, I want to do principles of least privilege. So I go through the actions. Let's say they can list all the buckets. That is the only action I want them to perform on my account. So I will select that. There are more, so you can see, I can expand all, and you can see there's a lot of API calls that you can make. Okay, Darius, go on.
So the question is, can I add actions? Is where those actions are?
Yeah, so these are, you cannot, let me answer the question carefully.
Okay.
So
okay.
This is what happens. First, you need to understand this. Okay, where is my whiteboard? Good. I want to demonstrate this before I answer your question. Maybe you can get an answer to your question. So this is AWS, and I want this to be drawn properly. This is your AWS account, or this is AWS in general. And so this is AWS, and this is our user. This is our user. Now, when a user want to access AWS, in front of AWS, there is an API, okay? So we call it the REST API. Do you understand? So you make a call to the API, and then the API talks to the service. So it could be S3, they all have their APIs. It could be EC2, they all have their APIs. Now, take note of this. The APIs we have API actions. So for instance, if we are talking about HTTP API, we can post, we can put, these are the API calls we can make to an API endpoint. So we can perform these actions. Whether you are using the console, whether you are using the CLI, you are still talking to this, just that you can click buttons to do the same, or you can write. Now, if you want to write your own API calls, okay, then you can actually write your own way of integrating or communicating with this, and you can do that programmatically. You get it? So you can do that programmatically using the API, the REST API. So your application or your CLI, you can program it to make its own API calls to this. But here, AWS has given you all the list of the API calls you can make to the REST API endpoint. Look at it. So you can select from all this. I hope I've answered your question.
Perfectly. Thank you very much.
Thank you. So in this case, I just want my user to see only the S3 bucket in my account. I can add that and then click next, okay, and give my policy a very nice name, like, okay. All right. Okay, so I have to specify the resource, of course. So with the resources, I can call a specific resource, and you add the resource using their identity on AWS, which we call the Amazon resource name. If you want all resources, which is not a best practice, then you can do the same thing. So you specify the resource using its resource name, and you can go and copy, for instance, S3, you can go and copy the resource name and come and add it here, and that can talk to AWS. Okay. Attribute-based access control. Can you elaborate on your question?
So yeah, like you've highlighted policies that are maybe identity based, resource based. So that these scenarios where someone is assigned access based on maybe the attribute or what they are, something like that. So maybe I just need clarity on that.
Okay. So if I understand your question, we can actually also assign access even based on their IP address that they are coming from.
Yes.
Does that? Yes. So mostly we use that in resource-based policies, okay? Because there it is people,
Okay.
it is resource access. So the resource can say, okay, allow access to a particular probably block of IP address, especially in on-premises where we have our own IP CIDR block we use, or even from a specific region. Do you get it? So those are usually on resource-based policies. All right. And I think let me talk a little bit about resource-based policies before we continue. Jacob, you are saying something. Continue.
No, it's okay. You have answered what I was asking about.
Okay. All right. So resource-based policies, there are a few things you need to know. The same thing, but I gave you an how to access them. With the resource-based policy, there is one thing that must be visible, the principal. And the principal is the thing that you are allowing access to. So we call it you can use the pair to understand what that policy is. I'll show you an example of that, but let's continue in what we are learning, then we come back to it. So in this case, we have the policy documents, then we have the we can put them in group, and then we can attach the policy to groups. Now there's something that happens. Let's look at this, and I'm trying to teach everything all at once. So don't forgive me if I'm just going back and forth. You see, I have a group of users in here. I have a group of users. So in here, I can create a group and add my user to that group. So for instance, let's say Uganda group. I want to do that using your name. Uganda group. So my deputy is coming from Uganda, so I'm going to add my deputy to that group. Okay. Now, when I do that, the question is that the policy of that I added to my deputy still work? Because remember, if I go to the groups and I click on my Uganda group, I have one user, but the group has no permissions. My question to you, and this is thought-provoking, think about it. Does it mean that the policy that the user brought to the group still applies? So when we click on the user, we will see our deputy user. We will see the permissions that the user inherits. So let's look at something. To answer the question, let's look at something. We see the user has a permission, okay, and it's loading the policy. So give it a second to load. Whilst it's loading, let's add a permission to the group. So for the group, we can add, let's say, another policy and say, okay, let's attach a policy. And I'll answer your question, Olu. That's a very good question. So let's keep. Let's say I'm saying that to this group, I want them to have read only. So I'm going to say read only permission, access to my AWS account. So read only. I want to select by job function. Yeah, so read only means they can only see resources. They cannot do anything apart from seeing. So now we go back to the group and we see the group has permissions. Now the users inherit, or every user in this group inherits this permission. And the same thing happens. The user that comes with the permission, they can also use the same permission in the group. But there's something that we can do. And look at this. Under the user, give this a second. Under the user, you will see that there is something called resource permission boundaries. That's what I want to talk about. So you can have a group that says, okay, in group Uganda, I want everybody. So this is the Uganda group. So UG group. I want everybody to, let's say, create an EC2. I want everybody to, let's say, terminate an EC2. These are the API calls I'm allowing. Terminate an EC2. I want everybody to create an S3 bucket, everything. But then I don't want my deputy to be able to access S3 bucket. Now, in this case, you see, my deputy is a member of this group. They inherit all these permissions, but I can limit them using the permission boundary. So permission boundary, I can say, okay, in this group, I want this user to only have this maximum permission. It means they can only access. So if I set the permission boundary, these are the policies assigned to this user. These are the policies. But I can control what they can do. It means I can say, okay, with these two policies, I want them to be only able to access only one of them. So even though you are in a group with a lot of people that have policies, permissions to do a lot of things, you can be limited in the same group. And we use this in the case, let's say you are a senior cloud engineer in a company, and then I was added to the company, and I am an intern. Okay, I don't know much about the company. You add me to a group of users, you can limit my permissions in that group. So I can say, okay, I want this user to only perform a specific role in the group. Is that okay? All right. So to answer your question, you see this thing here. You see IAM role here. IAM role here. My pen, where are you? Okay, you see this here. This is another way of assigning or allowing access to our AWS account. And this is for temporal access. So a role allows you temporal access to an AWS account. Look at this. This is me in my account. I am in my account and my user has a lot of administrative permissions. So if I want to perform tasks in the account with a limited or even further enhanced permissions, I can use a role. So a role, in this case, I have multiple roles in the account. I can create a role and say, okay, in the same user can access the account, but only with limited permission. So you see this row here. This is a row with, it's a temporal identity that I have created. So I gave the row a name called audit row, and I've assigned permissions, only read access permissions to the row. Now, when you look at the row, it is also a principal. So it also work with the identity-based policy. You see, these are the tasks that the user can perform. In the same way as the user is performing, I can say, okay, now I have a row. Let's say I have full permissions on my AWS account. I can switch the row. So let me switch row. I can use that row to access the account, and that is going to either limit based on the permissions given to the row, limit or upgrade my permissions. That is what a row is. So to answer your questions, Olu, we can allow an AWS service to access AWS on our behalf. Okay, we can allow AWS services to access AWS on our behalf, and to be able to access that, they use roles, and that roles are what we call service roles, and the policies assigned to those are the service-based policies. Is that okay? So here I am accessing the audit role. So let's see, let me give it a color and let me switch. Now I am in the same account. Yes, Darius.
You mentioned that roles give temporary access. I don't know that so does it mean temporary means there's a time frame?
Yes, there is a time frame, and I'm coming to that. So now,
okay, sorry.
Yeah, I am in the account, but you can see something. So this is, I assumed a role. And in this case, let's say I want to create a user. Okay, it is read only. So I want to create a user. Let's say I want to create Darius in my account as a user, give them all the permissions, everything. You see, give it a second. I want to create only a user. But to generate password and blah, blah, blah. I know this will not work. So I'm just going to attach permissions directly, give them full access to the account and create the user. You see, I'm not allowed. Because even though it is me in the account, I have assumed another identity. Do you understand? And this identity, the permission says I cannot do all this. So it says I'm what? Denied. You get it? I'm denied access. So let me switch back to my AWS account. Let's switch back to my IAM user access and see what happens. So I'm reloading back again to the original account that I am in. So when you look at rows, when we create a row, we can assign the duration of the row. That's why I said limited. So when you click on the audit row, you can see maximum session duration. Okay, so I can only assume that row for 1 hour and it expire, and I have to re-assume again. And it will expire again for 1 hour. You get it? Then you can see the activities and all that in here. So last access, I can see the last time I accessed using this row. The trust relationship you can see here is that even though you create a row, you have to determine which user can access the row. And that is what we call the trust relationship. So the IAM user that can access the row is the trust. And then there is an AWS service that actually allows you to assume rows. It's called Amazon Security Token Service. And what happens is that when you assume a row, if you assume the row, Amazon STS creates temporal access key and secret access key. Secret key, let me say secret key. And these are the identities that you use to access AWS. Now, what is access key and secret access key? I'm touching up on everything to be able to cover a lot. Users, to be able to programmatically access AWS, we give them programmatic access. So my deputy user like this, if I want my deputy user to have access to the account through the CLI, then I can come to security credentials and give them access key. So you see right now they have no access key. So it means I cannot make API calls. So for instance, let me go back to my CLI and say, let me clear the account, the terminal. I want this away. Okay, so let's go. In my CLI, I can say, okay, AWS S3. I want to list all the buckets in my account. So I'm executing this using the programmatic access. When I do this, it gives me a list of all the S3 buckets that I have in my account. But let's say I want to do the same thing with a credential. So I want to do that with my deputy profile. When I do it, that does not even exist in my console. So let's see, how can we allow our IAM user programmatic access? I create an access key. So this is what I use for programmatic access. And I'm doing that. Once I do that, create the key, it gives me an access key and a secret access key. And these are like when you are doing SSHing, you have secret key and private key and public key. So this is the access key is public and the secret access key is private. So let's go back to my console, and what I do is AWS configure to configure access of a user. So I'm going to say profile, give it a name because I have multiple accounts, so I have multiple profiles. So in the terminal, we can give specific profiles. So I'm going to call this deputy. So once I do that, he asks me what is the access key of deputy. I paste what I have copied. Let me paste that. It says what is the secret access key. Let me come back again, copy and paste that. And paste that. Okay, why am I using shortcuts? Okay, and they ask me what is the region. So I give a default region. I want US East 2. He asks me what do I want the output. I want them in JSON. I want to see this. Now this is done. So the same, let's go back again and say perform this API call. We want to list S3 buckets in our account, but now we want to use the deputy profile. When I run that command, it's going to work because now I've configured. You see, it has worked. I've configured that access, security access key and the secret access key for my account. Are we good? Give me thumbs up if you are following or if you are lost. Okay, so I'm going to give us 10-minute break. We come back and then we dive into resource-based policy because we have a lot to talk about. So 10 minutes, we come back and talk about resource-based policy. So drink some coffee and let's continue. All right. Who is back?
Yeah, I'm back.
Okay. All right. All right. So,
Joseph,
hello.
yeah, can I quickly ask this question, or should I
Go
wait
on.
till everyone is back?
Okay, you can ask. It's time. The time is up, so everyone should be back.
Yes. The question is it possible to deny user access to multiple resources using same JSON policy, or you need to do one after the other to deny access? You know, looking back to that JSON code where you can give access or deny access. So you can say, okay, access denied to S3 bucket. Is it possible to add additional resources in the same JSON code to deny
Okay.
access?
Okay. So, is my screen visible?
Yes.
Okay. So this is an example of an identity-based policy, as you can see. And in the same policy, we can have multiple statements. Okay. We don't need only one statement. We can have multiple statements to perform different level of control. But here we can deny this. It's not only allow, it's allow and what?
And deny. Okay.
Okay.
Yeah.
So when we deny, one thing about, and that is the next thing I wanted to talk about, how the permissions are evaluated. There's no need writing deny, 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 deny. Because if the person doesn't have any policy, they are automatically denied. You get it?
Okay.
Yeah.
Yeah.
You only need to write allow when there needs to be allowed. But then you can,
Okay.
you can deny them. You can deny them from stopping EC2 instances. You can deny them several actions. In fact, you can deny them all actions.
Mm.
You got it, and we call that explicit deny.
Okay.
You got it. So you can do it. And then someone asks a question about condition. Yes, you can. You do use a condition, maybe a specific tag, a specific user. Conditions can even be a specific IP blocks. You can specify what they can do. You get it?
Yeah, got it. Yeah,
Yes.
thank you
Yeah.
so much.
Yes. So as I was saying, let me continue. I hope everybody is back now. So as I was sharing with you, this is a sample of a deny. Do you understand? And this one has denied every action on EC2 instance and every action on S3. So any user with this resource policy cannot do anything on EC2 or S3. Do you get it? And then the same, this is an allow version. I mean, this is explicit allow and explicit deny, specifically allowing or denying. Okay, so there's a question. Are roles only for user resources or for actual users? Roles are for users. So roles are for principals. Okay. Okay. And when we say principal, it means users, groups. Okay. And what happens is we have services. AWS services like Amazon EC2 can assume a role to make a call on another service. And I will show you that in a moment. Is that okay, Femi?
Yes, because I asked this question because I read somewhere that roles are specifically for services and also federated users, but which you probably come to later. So that's what I wanted to clarify.
Okay, so when we say Fed, I think for federated users, finish. Let me respond on that. Sorry.
No, that's why I wanted to clarify because I had assumed that users for like individuals, and you can then attach those individuals to groups with particular policies, blah blah blah, and that roles are for services or resources accessing your account or your resources as well. So that's why I put in that question.
Okay, so we can also use it when we say federated users. What we are simply saying is that users that are not in your account. Do you understand? So let's look at this. If I'm going to create a row in here, if I'm going to create a row, I have the option to choose an AWS service, okay, an AWS account, and a federation. This is Samba 2.0 federation is for, let's say, on-premise. People who have on-premise authenticated users can also access AWS as federated users. We can also federate a web identity. You get it? So somebody who is not part of your AWS account can assume a temporary role with controlled permissions to come and perform some tasks in your account. So you see, if I select an AWS service, then I can create a role for an EC2, Lambda. Maybe Lambda needs to access DynamoDB. Can create a role for Lambda so that when it's accessing, it can present that credentials as accessing. You get it? And then we have account. So it can even be for my AWS account or for another AWS account. And this is what we call the create cross account role. You understand? Femi, is that okay?
Yes, I understand. Thank you.
Good. All right. So the policies, we have the explicit allow and explicit deny. Explicitly means you have a policy that performs the task. But then if you don't have a policy, then automatically no user has any permission as far as there's no policy. And this is how policies are evaluated in a way. So, you know, we can have multiple policies. You can have several policies in your account. So what happens is that IAM brings all the policies together and asks the following questions. Is there an explicit deny? And in AWS, deny has power more than allow. So deny is always the most looked for policy because it, in a way, it allows you to control users when you want to, intentionally. You get it? So if there is an explicit allow, deny, then it denies. So every policy that contains the, if the policy contains an explicit deny, that is taken into effect first. Then it looks for, okay, so if there is none, then look for an allow. Is there an explicit allow? Does the policy state that you are allowed? If it does not exist, then move on. If it exists, then it performs the task that the control that you are allowed to do. Now, if you don't contain any both allow and deny, we have what we call the implicit deny. It's like you are born without a father and a mother. You are, you don't exist. So that is what happens. All right. So back to resource-based policies. So I said resource-based policies are used for on resources like Amazon S3. So we have an S3, and let's say I'm hosting a website in this S3 bucket. So let's look at this S3 bucket. So I have a lot of buckets in my S3, and let's say I have this one. And on this bucket, I'm hosting the websites. It means I have to control people who can access. It's not only website, it could be any object or any data in the bucket. So I have to control access to the bucket, even though another form of identity-based access was used to allow whoever created the bucket to be able to create it. Now I have to control direct access to the bucket. So when you are coming to access the bucket will ask you, who are you? You have the credentials, blah, blah, blah. So if I click on permissions, you will see here. So we have an example of a resource-based policy, and here we are calling it a bucket policy. So in this policy, you will see that, as I said, it contains pair. You have the principal, effects, action, and the resource. And mostly the resource is not compulsory because the policy is directly attached to the resource, but anyway, it can be there. So this is the principal. Everyone is allowed. So it means everyone, I can say a specific principal. Then we have the actions. In this case, view the object in the bucket. Then I have the resource. So I specified the bucket identity, and you can see that already in the policy. So this is a resource-based policy, and the effect is allowed. So what happens is that if I go back to the packet endpoint, and I give this packet endpoint to everybody, it means you can access whatever is in the bucket. You get it? Because of the policy. So the policies allow that access to the content in the policy. So that is what resource-based policies are used, and they allows access to specific resources. So it's attached to resources. Take note of that. So as you can see, as I said, now all these are needed for control. And there was a question that, do we only have? I think there was a question like that. Do we only have resource-based policies and identity-based policies? The answer is no. But we have two policies for granting and controlling access. Okay, and that is what we are talking. We also have what we call service control policies, which we will look at as we continue. So in this case, when a user want to access your AWS account, they can do so using a role which is temporal. Okay, and then they can then we can also use their identity. So if they can use their user identity, regardless of what they use, we control them with what? The identity-based policies. So we can allow or deny access. Then when they are accessing a service, we can also control the access to a service like an endpoint or an S3 bucket. We can control it using what? Resource-based policies. So this all control is like a double layer defense. Then, as I said, we use permission boundaries to control specific users, especially when they are in a group with multiple permissions. We can use the permission boundary to control their permissions. So in this case, we have the maximum permission is being set by the permission boundary, and then that permission is granted based on that. Okay. Any question? Do you have any question? Can give me thumbs up if you're okay. Okay. So there are cases that you have multiple AWS accounts. Okay. There are cases where you have multiple AWS accounts. You can have in the company, you can have an account for accounting, you have an account for management, you can have accounts for developers, you can have an account for quality assurance, you can have an account for even DevOps. So in that case, how do you control security for them? And this reason is actually an encouraged reason. You need to use multiple AWS accounts. You can have a security account purposely on AWS. You can have a login account to log everything happening in the account. And in that sense, we use what we call AWS organization. So if you have many teams, you have multiple teams in your AWS account, you have multiple teams, and you want to pay the bills. We call it consolidated billing. You want to consolidate all the bill into one large bill and pay as an organization. Then you use AWS organization. In this case, as a developer or whoever is in charge of that, you can control all the accounts. Remember when I asked you about if you use your account for Uber. So you can control all the accounts because they are part of an organization. So let's say we have account 1, we have account 2. They have different users. It could be root users. It could be IAM users. When they join an organization, you can control, you can put a guardrail on the policies that are allowed in this organization. An AWS organization, when you create an organization, the account that creates the organization, we call it the management account. And you can put all these different accounts into what we call organizational units or OU. So let's say we come to this OU can be, let's say, DevOps OU or security OU. So in there, we can have another account performing pipelines, creating pipelines. We can also have another account performing code build and testing and all that. So we can have multiple accounts and there are multiple organizational units. And in this case, we control them using what we call the service control policies. So service control policies actually is a guardrail on the allowed actions in the organization as a unit. All right, so here is what happens. So let's say in your account, our user that we created, the deputy user, they have in their identity-based policy, they are allowed to EC2 and IAM. But in the organization, we create a service control policy and say we are only allowing S3 and EC2. What happens is that the only policy that is common to the two of them is allowed, which means the user can only perform EC2 functions. They have to have a policy, IAM policy, that says they are allowed to S3, and then the service control policy should also confirm that. If not, then they are allowed to only what the service control policies do. One thing you should know is that they do not grant permission. It means they do not allow or deny. They only say, okay, this is what you can use. Okay, this is what you can use, and that is it. So in the defense of our AWS account, we use all these to filter. So if it is an organization, we are using service control policy to control it. If they are in a group, we can use permission boundary to set the maximum permission. Then we can use the identity-based policy or the resource-based policy to deny or grant permissions to our users in AWS account. I will give 30 seconds for questions. Do you have any question you would also like to ask before we continue? Any question from anyone? Terence, am I audible?
Yes, you're audible. I think there are no questions.
Okay, all right, thank you. I know it's a lot. So as you can see, what I'm doing, I try to demonstrate a lot because you can go in and go and also try to create these things. You can create an IAM role. You can switch the role and see how it works. Now, there are cases where when organizations are coming to AWS, okay? For instance, if somebody is coming to sell you a drug, I don't know in Uganda, but in Ghana, we ask the person, are you sure this medicine is FDA approved? Right? In Nigeria, they say, are you sure this is NAFDAC approved? Right? In Uganda, what is your Food and Drugs Authority? What is that
name? NDA, National Drug Authority.
Okay, so NDA. So before somebody can produce a drug and sell, they have to go for NDA for authorization, right? The same thing happens in AWS. So in AWS, there are rules controlling cloud computing. So before you can create any service at all, your service should be compliant. It could be, if it is in Europe, it could be GDPR, okay, privacy policies. It should be compliant to them. It should be, maybe if your service stores health record, it should be HIPAA compliant and many more. ISO compliant for electronics and all that. So AWS has a service called Amazon Actifat. And what you can do is that if you want to access the AWS compliance report from auditors, you can use Actifat to access them. So you can go onto AWS Actifat, and then you can see all the compliance. This is very important because if you are going to deploy an application for European users, there are policies that there are some compliances that you need to follow. So you can use this service to be able to access the compliance reports. So when you go to AWS as you go to write the exam, you can see questions like, okay, if a company wants to check the AWS compliance reports and see, okay, is AWS compliant with the services that they are going, the application that they are going to deploy, where should you send them? You have to redirect them to Amazon or AWS Actifat. And here you can view the reports. So you can see review third-party reports about the AWS environment. Okay. And you can also see the compliance, let's say the authorities that authorize them, like ISO 500 and all that. All right, so here, this is an accessibility conformance report from an organization. This is on a specific policy for Amazon Cognito user pool. So let me search for, let's say, if my application is going to access health records, I can look for HIPAA compliance reports. So we see customer compliance guide. You can search for this report and see even agreements that are also created in there, or signed contracts that are signed in the contract agreement signed. All right. So that is one thing about AWS, and you can use Artifact to access what is allowed and what is not allowed. So we also have what we call the Customer Compliance Center, and you can use that to learn about AWS compliance. When you are using cloud, how do you make your environment more compliant? All right. That is security about users and all that. But then we have applications, because we deploy applications on AWS and we want to secure these applications. It means we want to make sure that our applications are encrypted, they are protected from malicious access. There are a couple of AWS services we can use for protecting our applications, and one of them is Amazon Web Application Firewall. So if you have applications on AWS like databases, and you want to protect against SQL injection attacks, okay, so if you want to prepare against SQL injection attacks, okay, so SQL injection attack or cross-site scripting, you can use Amazon Web Application Firewall. It's just there. It's a feature that you can, a service that you can use to filter your traffic to protect against malicious attacks on your web applications. So it protects against SQL injection, HTTP flood, and all forms of attacks. It is integrated into services like CloudFront, Application Load Balancer, and Amazon API Gateway. So how do you use that? You can use it to create rules. So we can have allow rules or deny rules. And these are like firewalls. So these rules can then allow or deny access based on maybe IP address or locations or a particular block of source IPs. So you can use that to filter against these attacks. Then there is one attack that is very common and in online, and that is DDoS. Who knows about it? Someone could explain this to us. What is DDoS attack? Okay, Jacob, you want to explain? Okay, go on, Femi.
Denial of service attack.
Okay, so this is double D. So this is distributed denial. What does it mean? What is it?
I think it's when deliberately people load your system with requests so that the system, so normal users don't get access because they are repeated requests to your system.
Okay. All right. Thank you, Felix. Jacob,
Okay.
add on.
Yes, so for DDoS attack is distributed. That means that it is using a bot or using other machines to send a large volume of requests to overwhelm the system.
All right, thank you. I always say the easiest way you can understand distributed denial of service attack is that imagine who is unmute here. Let's say Femi, can you unmute your microphone? Let me show you something. So Femi is an application running, and when we make a request, Femi respond, right? So if I call you Femi, can you respond? So when I say Femi, you say yes, right? Femi?
Yes.
Okay, so Femi is doing that. Now, you see, Femi, because I'm the only person saying Femi, Femi can respond to me. But let's say I say Femi, by the time Femi responds, I say bring in another request. And then by the time he responds, I continue to overload Femi with a lot of requests. Then Femi cannot do much. You see that since he's a human being, he'll get angry. But it's a computer, it becomes very slow and probably it breaks down. That is denial of service. But then that can easily be prevented because Femi can just mute me right now, and then I cannot talk to him, right? So how do we then do that? To avoid Femi to prevent against only me, then everybody in this class is saying decide to unmute and decide to forward request to Femi. So you can see, Femi, what will be the implication if everybody is calling you and you are supposed to respond to the questions that they ask?
I'll be overwhelmed.
Yes. So that is the distributed denial of service attack. And this way is difficult to protect against. But AWS have services that performs that. And we have one called Amazon Shield. So Amazon Shield protects against both the distributed, the denial of service, which probably is one hacker that trying to overwhelm your service, to the distributed denial of service where they use bots and even other systems to flood your network from multiple sources and multiple geographical locations. AWS Shield can protect against that. So you can enable Shield, but Shield comes at a cost. Okay, Shield comes at a cost. So we have the basic and then Shield Advanced. It comes at a cost. So for instance, if I go to CloudFront, let me go to CloudFront, and let's say I'm distributing applications and I want to use Shield I want to enable Shield to protect against my account. That is use Shield Advanced. It costs almost about $3,000 a month. So depends, unless you are using a very advanced use case, you have to be very careful when you are using Shield. So let's say I'm creating a distribution. I go in and I want to protect this my endpoint against distributed denial of service account. I can also use WAF, web application firewall, which costs around $14 for 10 million requests per month. And I can also add the AWS Shield as part of it, and that causes way more than that. So you have to take note of that before you implement Shield and all these services in your AWS account. So let me see. Where's Shield? I think it's somewhere, I can see, but yeah. So you see, okay, this is Origin Shield. This is Amazon Shield. So that is one. Then there are other ways you can also protect your application. So you have an EC2 instance. How can you protect your instance against malicious attacks or even on-premises servers? You can use a service called Amazon Inspector. And what it does is that it assesses your application. So it scans your applications on your EC2 instance. And when it scans it look at provide an assessment for vulnerabilities and maybe deviations of your account from best practices. Take note, this works in EC2 or Amazon Elastic, let's say container registry, ECR, or code comments. These are places where you can use Inspector to scan your environment for accessibility, for best practices, and maybe for vulnerabilities. So take note of that. Now we have other services like AWS config. What do we use it? What do we use AWS config for? Any idea? Am I audible? Everyone is lost. Felix.
Yes, Joseph, you're audible.
Yeah. So what
Like it,
have you
just
ever heard of?
Yeah, but
Go on.
so it's yeah. So basically, it provides with where you can track the configuration changes to various AWS resources over a given period of time.
Okay. So if you are working in an organizational environment, you can track the configuration changes. Okay. Or then you can enforce remediations. So that is AWS config. There are other AWS services that we can use in several cases, like the Amazon Key Management Service. Now, this service, thank you for this. This service allows you to perform encryptions, or if you can save your encryption keys or create encryption keys in your AWS environment. Now, in this case, there are two ways of doing this. Let's say some organizations, they want to manage their own encryptions in there. That is, they create their own keys and manage them. That is okay. There is the customer managed keys that you can use. And then sometimes organizations also want to manage the hardwares that create the encryptions and manage them. So in this case, we have the Cloud HSM. So Cloud HSM is used mostly when organization wants full control over the models that perform the encryptions in their environment. So they can use that. Or if you want an AWS service that creates and control the encryptions, then you can use KMS. And in this case, you can use AWS managed keys or customer managed keys to encrypt your resources. Mostly what I say is that encryption is available for a lot of AWS resources, and make sure when you are using them, you enable them. They are like seatbelts. If you don't enable them, then your resource can be used. There are two forms of encryption that I like to talk about, and that is encryption at rest, okay, and then encryption in transit. Who can explain this to us? Who can? Anyone? What's the difference between encryption at rest and encryption of data in transit? Let's Darius go on.
At rest, let me start with transit. And transit, let me say I want to log into my account. To put my password, it can be in plain text. So when I'm remote, I'm trying to log into a remote server. So I can encrypt my password so that somebody can't just, let me say, man in the middle to see my password in plain text. Then
Okay.
at rest, let me get at rest is, let me say I have some information in an S3 bucket. I have some objects in an S3 bucket. I can go ahead and encrypt them. So that is at rest. That's what I understand.
Yeah, exactly. That is I think very good. Thank you.
Oh,
So
okay. The in transit, I would say, okay, when I'm transferring some information into the bucket, I can encrypt it while I'm transferring them into the bucket.
yes. Okay. So usually when you are moving data from a destination to another destination that is in transit, and people can actually perform a man-in-the-middle attack to snoop on your traffic. In this case, to avoid that, you can use TLS, or SSL certificates or encryption to encrypt the data in transit. That even if they intercept it, it becomes gibberish. They cannot work with it. And then when something is at rest, let's say you have data in an S3 bucket or on your EBS volumes or your EC2 instance or in your databases, you encrypt them to avoid losing it if someone accesses them, especially critical sensitive data. Then we have another AWS service called Guard Duty. And Guard Duty performs threat detection. And what it does is that it scans our AWS account, okay? So it performs threat detection in our AWS resources, okay, and the infrastructure. So it just continually monitor the network activities and the account behavior, and then it can determine, okay, if there is a threat. or there is a malicious activity going on. So it's continually doing that from our VPC flow log, the DNS logs, and once it detects a threat, you can review the findings, okay, in the console. I think that's a very nice question from Darius, and then you can take remediations in them. Now, the question, the difference between GuardDuty and Amazon Inspector is Amazon Inspector runs on EC2. So Amazon Inspector, you can have an agent and install on servers to scan the servers for vulnerability. Do you get it? So that is basically, it's limited for that server environment. Meanwhile, GuardDuty is scanning the entire environment, including the network and VPC flow logs, okay, including the VPC flow log. That is something that Inspector does not do. Inspector resides only on the server, and it performs its own threat hunting on that server. Is that okay?
Yes, it's okay. Could I relate it to shared? Could I relate it to shared responsibility, whereby I would say, for Inspector, it's my responsibility. Then GuardDuty is AWS responsibility.
No, GuardDuty is there. You can enable it or not. So it is also
okay. It is also my responsibility. Okay.
Yeah. So you can enable it so that it can be scanning your environment, okay, for threats, okay, and the account activity, and then you can disable it. So I don't have it run in my account. Continue. Okay, so vulnerability detection. Yeah, Felix has provided that for you. But then there is something, and this is something that a question I was expecting. Okay, what is the difference between trusted advisor and GuardDuty? Anyone has an idea? Or what is trusted advisor? Idea? Okay, Jacob, go on.
Yeah, so I think for trusted advisor is to do with like it helps do much with the like optimization of resources in terms of cost and even security.
Okay, all right, thank you. So trusted advisor is more or less like a guidance, a guide. Okay, so what it does is that it also scans your environment, okay, and provide guide on this, the well-architected framework, okay, how you can optimize your costs, how you can increase the performance. So if you have a service, let's say I have an EC2 instance and I have allowed public access to it through the security group, you can say, yeah, this is something that is not based on best practice. So you have something that you have to investigate or take an action on. If you have a resource that is running and you are not using it, it's going to incur more cost for you. So trusted advisor can say, okay, you are not using this service, but it's been running. Can you turn it off? Okay, so it gives you recommendations or guidance on how you can adhere to security, performance, cost optimization, and then other ones, other limits in there. So that is with trusted advisor. Any question on that? Okay. So when it comes to AWS, in terms of security, they are okay. Jacob, your hand is up.
Yes, so maybe I just need clarity. So GuardDuty is more targeted to EC2, right?
Come again.
I'm saying is GuardDuty more targeted to EC2 services?
No, Inspector is more targeted to EC2.
Okay, all right, thank you.
Yes, yes. GuardDuty is the entire account.
Okay, thank you.
Good. All right, so let's try this knowledge check and then we call it a session. I think today there are a few other services we could talk about that is Amazon Mercy. You can read on them. Amazon Mercy. Okay. And then we look at Guard Duty, we look at Shield, and then you can also look at the AWS Firewall Manager. So in terms of security, there are a lot of services, but for your level, you don't have to advise to disturb yourself too much. So we have these two services that I've not spoken about, so you can review them. So let's release the stress. Which option describes an identity and access management policy? A, B, C, D. A, an authentication process that provides an extra layer of protection for your AWS account. B, a document that grants or denies permission to AWS services and resources. C, an identity that the user can assume to gain temporary resource access to permissions. D, the identity that is established when a user first creates an account. Put your answer in the chat, everyone who is here. A, B, C, D. Which one do you think describes an IAM policy? Okay, I see B from a lot of people. So yes, the answer is B. All right. An employee requires temporary access to create S3 buckets, several Amazon S3 buckets. Which option should be used for this task? We have the root account, or the AWS account root user. B, identity and access management group. IAM role or service control policy. So now you have the idea. So we use the IAM rules. Okay. Which of the following description best describe the concept of least privilege? So A says adding an AWS identity and access management user into at least one IAM group. B, granting only the permissions that are needed to perform specific job tasks. C, checking a packet's permission against access control lists and performing denial of service attacks that originate from at least one source. So the answer is B. All right. Which service helps protect your applications against distributed denial of service attack? We have Guard Duty, we have Inspector, we have Artifact, and we have Shield. Yeah, this is where it gets people confused. Yeah. So the answer is Shield. And WAF, AWS Web Application Firewall, protects against cross-site scripting and SQL injection attacks on your applications. All right, next one. Which tasks can AWS Key Management Service perform? A, create multi-factor authentication. B, update the AWS account root user password. C, create cryptographic keys. D, assign permissions. So C, create cryptographic keys. Yeah, you are all right. Okay, so we look at the shared responsibility model as a mindset change in how we understand security in AWS. Make sure you cover your end of your security, or in other ways to prevent most of these security issues. You can use what? AWS managed services or serverless services. Take note of that. And then we also look at the IAM and the features. So we know that IAM can be used to grant and grant access to AWS resources. We can also be used to control access to AWS resources. So we have the AWS managed policies, and then we have the customer managed policies. Both policies, we can all use them to perform the same activities. And what happens is that we have the resource-based policies for resources, and then we have the identity-based policies for IAM roles, for users, groups, and that. All right, so we also look at how we can secure our applications by using encryption, like the KMS, securing our environment using Guard Duty, detecting vulnerabilities on our servers using Inspector. And then we also look at where can we get compliance report. How do we know that AWS has been authorized to provide these services? We can use Artifact to do that. Thank you very much for your attending. If you have any question, you have about 60 seconds for Q&A, or I hand over to Mr. Terence and the leaders of the session. Thank you. All right, Mr. Chiviri, are you here?
All right, thank you, Joseph, for that delivery. Security is critical, but it's also a very long module. What I'll do is I will immediately share the reading handout just now for you to fill in any of the minor areas. I think like Messi was not touched, but it will be part of your self-directed reading. In the interest of time, we will just let that other part of it for you to handle it in self-directed reading from the handout. I will send the handout to the group leader, and the group leader will share it with the rest of you. We are moving, and we are moving very fast. I think we have now less than 3 topics to finish this thing. So we have got like the next 3 upcoming Saturdays for us to wind up on the syllabus delivery. Then after that, we will just do things that are essentially what I would call exam and certification preparation for the large chunk of what did we call it? November, month of November, and we will call it that this boot camp ended. So that is just it from my end. Maybe I can call upon Isaac if there's any other announcements.
Yes, there is. Thank you so much. So just to ask, you suggesting that we shall not have, because the initial thought was that next Saturday we can have a second session on this topic, so that you can bring it to one like a comprehensive conclusion.
Actually, what is remaining is very minor, in my opinion. But let me talk to this gentleman here, Joseph.
Hello, Terence.
Do you want to see these people again? Because I think there are certain aspects that maybe. Did we talk about Identity Center? Other than Messi, did we talk about Identity Center?
No, we did not talk about Identity Center.
Okay. My question is, do you have the time for that, Mr. Joseph Tete? Is your Saturday taken?
Oh no, I think I don't have any plan yet, so I could.
Okay.
You can
do this, Isaac. What we will do
it.
is we will align and we will confirm, and then he will complete the security, identity, and compliance in its entirety.
Great, that's fine.
Mm-hmm.
Okay, so on that, I will think I'll follow up with you, then I'll update the team accordingly.
No problem, no problem. But on my part, I think I will send you what I'll call security, identity, and compliance handout 1. There are 2. Okay. That's what I was telling you. This thing is long. This particular module is long, but in the world we are living in today, it has become a very critical module.
Yes.
And I promise you, starting now into the future, you are never, ever going to do any IT exam that does not have security in it. It is now just, I mean, security issues, there's no way to avoid them.
All right, I think that's it. We shall wait to hear from you. Then we'll update the team accordingly. And then we'll touch base next Saturday, starting the same time.
Okay.
A big vote of thanks to Joseph for his continued time and sharing of knowledge with the team at will.
All right.
All right. I think that's it. Have a nice weekend all.
Okay, let's call it a class and then we link up come Saturday next week. Huh?
Sure.
Okay, I will be sending you security, identity, and compliance handout 1.
Okay, yep.
For at least for you to do your own self-directed reading on the areas that Joseph worked on today, yeah?
Okay.
Okay, just a minute. Just 1 minute before we disperse. Because the problem is sometimes when I leave you, I normally run into my other life-related and weekend-related problems, and then I entirely we go to see if okay. Yes. What I want to do is I want to send to you security, identity, and compliance handout 1 right now, such that I do not forget.
Okay.
But the layout of what needs to be covered, that had already been done. Isn't that so?
Yes, yes.
End to
That's
end.
on
So
the-
I'm sending handout 1 right now. You can share it with the people.
Okay.
All right. I think that has been done. You can confirm if it's received on your, what is it? On your,
email?
you can
WhatsApp.
confirm your email, on your email. I've sent it on the email thread.
Just a minute.
Should come in anytime now.
Not yet. Darius, have you seen it on your end?
I'm checking now.
It is security, identity, and compliance 1, handout 1.
Okay, it has come through.
Okay. So that one is the one that
Let's
at
see
least
it.
you can catch up on what we have been doing, and then what we will do is we will pick up with the second part of it next week. We'll study things like Messi,
Sure.
Identity Center. You know, what happened is we cannot, why we are not taking any risk is some of us did the CCP in the old syllabus, but I think Q4 last year, we moved from
Yep.
CLF CO1 to CLF CO2. So that's where I'm trying to be very hands-on in following up to ensure that you are not handicapped
Yes.
in any way when you go for the exam, such that we are up to date with where AWS is in terms of what they want covered.
Okay.
And always there is more new things, and always there is old things that became deprecated and are pushed out of the syllabus. So it is only justice that we give you the up-to-date content or the up-to-date delivery.
Exactly.
All right. So having shared that, now I think I'm a free man.
You're free man to go and enjoy your weekend.
Okay. I think I've been given the powers to enjoy my weekend. We see you next week, Saturday.
Next Saturday, I'll be enjoying with you the
Marathon.
weekend. If at all, we'll be in Nairobi. We shall catch up. We shall be in touch.
Come buy me a Tusker. I've done a lot of
I
work.
will. I will. I will buy your task.
Why don't you take Isaac? Why don't you take an IO special for him?
Yeah, even, but you know,
And someone
nowadays the
someone told-
aeroplanes, they don't allow us to carry things. Don't know, leave. You know, those guys, they're just very mean.
Okay, got you.
Okay,
Right, bye.
see you next week, Saturday.
Sure.